In this next simulation, we're going to be looking at phase change. So on the screen, I have a hot liquid and a cold solid. And in just a couple of moments, I'm going to withdraw the barrier and allow these two to mix together. Now, I have kinetic energy shading checked off here. So this is showing us the relative amount of kinetic energy that each of these particles possess. So the key here shows that the more white or gray the particle is, the lower the kinetic energy. And the darker the red shading, the higher the kinetic energy. So we can see in my hot liquid that I have a whole range of kinetic energies. There's some that have very little, and then some that have a lot. And we see that that kinetic energy is transferred particle to particle whenever they collide with each other. So sometimes a particle with very high kinetic energy will collide with a particle with lower kinetic energy, and they'll transfer some energy, and that lower kinetic energy particle might now be moving faster with more kinetic energy. So we really have a range of kinetic energies, a range of amounts of motion that all the particles have. When we look at our cold solid, they have some kinetic energy, but very, very little. We see that they can kind of just wiggle and vibrate in place. They can't move around nearly to the degree that we see with our hot liquid. So this gauge here is keeping track of the average kinetic energy of the large atoms. So once I withdraw the barrier, we'll be able to see what happens whenever the hot liquid particles collide with the cold solid particles. So very quickly we see that as we have collisions happening, that solid is no longer a solid. And now they all have about the same average kinetic energy. There's some that are lower, some that are higher, but on average, these guys all are the same, the hot liquid and cold solid. So I'll do that one more time. So if I withdraw the barrier here, we're going to see collisions start to occur, which means energy transfer is going to occur.